All right, scholars. This is part two of I Ready um mid mid-year diagnostic. So part two really focuses on helping students who are at like a grade 4 or grade 5 move along to like late grade 5, early grade 6, right? Part one will really focus on students who are on grade 6, early grade 6 or late grade 5, moving into middle grade 6 or late grade 6. So this assignment video is for all students. So let's go over this. So this question says select all true statements, which means there is more than one answer, right? So first you want to just analyze what do you have. So if I look and see, I see 4 smiles. I see 2 squares. And I see 6 triangles. Okay, so that's what I see. And we want to create some type of representation to help us understand what's happening. We're looking for true statements, and this is the information that we have. So we want to create a representation of the information. So we're dealing with smiles. We're dealing with squares. And we're dealing with triangles. Right? And so what we want to do first is we want to box out the information that we have. We have 4 smiles, 2 squares, 6 triangles. And we have A, B, C, D, E, F. 6 choices. So in order to represent that, I like to create something known as like a process of elimination representation. Okay. And this will help me organize whether an answer is true or false. So A says the ratio of triangles to squares is 2 to 6. Since triangles was seen first, we want to put 2 under triangles, and squares was next. We want to put 6 under squares. Then we want to represent that in our chart. Under triangles, we know it's going to be 2. And under squares, we know it's going to be 6. Well, to get from 2 to 6, we multiply by 3. And to get from 6 to 2, we divide by 3. There is no even multiplicative or balanced multiplicative relationship because we're dividing on one side and we're multiplying on the other. So that means A is incorrect. B says the ratio of squares to smileys is 2 to 4. Since squares was first, the number that comes first represents the item that comes first. So squares will be 2 and smileys would be 4. So on my chart, under squares, I will put 2. Under smileys, I will put 4. To get from 4 to 4 is multiplied by 1. To get from 2 to 2 is multiplied by 1. There is a balanced multiplicative relationship between squares and smileys by multiplying by 1. Thus, B is correct. C, the ratio of smiley faces to triangles is 4 to 2. Since smiley faces is first, the number 4 represents smiley faces. Triangles is 2, so the number 2 represents triangles. Do you see how I'm putting the number there? And so on my chart, under smiley faces, I will put 4, and under triangles, I will put 2. To get from triangles 6 to 2, I have to divide by 3. To get from 4 to 4, I have to multiply by 1. There is no balanced multiplicative relationship, so C is also incorrect. D, there are 3 triangles for every square. Every means 1. So under triangles, I want to put 3, and under squares, I want to put 1. And then I want to go to my original ratio and see if there's a balanced multiplicative relationship. To get from 2 to 1, I divide by 2. To get from 6 to 3, I divide by 2. Since I divide by 2 on both sides, there's an even multiplicative relationship of multiplying by 1/2 or dividing by 2. So D is correct. E, there are 2 smiley faces for every. We know every represents 1, and of course for smiley faces, there's 2. So under smiley faces, you want to put 2. For squares, you want to put 1. And to get from 4 to 2, you want to divide by 2. And to get from 2 to 1, you want to divide by 2. There is a balanced multiplicative relationship or of multiplying by 1/2 or dividing by 2. Thus, E is also correct. F says there are 2 triangles for every smiley face. So under triangles, I want to put 2. And under smiley faces, I want to put 1. To get from 4 to 1, I divide by 4. To get from 6 to 2, I divide by 3. This is not an equal or balanced multiplicative relationship between smiles and triangles. So F is false. So the correct answers are B, D, and E. If you got it correct, check you out. You are a star and you have an understanding of ratios, even with finding equivalent ratios, which is really, really good. And that will really support you in understanding your I-ready. Let's go to the next one. It says select all of the ratios that are equivalent to 9 to 6. Select all means more than one answer. Okay, so now we want to create some type of representation where things are being compared to 9 to 6. Let's do another table. We have 9 to 6. A says 6 to 9. B says 3 to 2. C says 13 to 10. D says 5 to 2. And E says 18 to 12. You want to compare everything to your original ratio or a ratio that is correct. All right. So to get from 9 to 6 and 6 to 9, there will not be a balanced multiplicative relationship because as you can see, it's the opposite. So off the bat, we know that A is incorrect. Now, to get from 9 to 3, you want to divide by 3. To get from 6 to 2, you want to divide by 3. Clearly, there is a balanced multiplicative relationship between both sides, so B is correct. 13 to 10. This is also incorrect because they share no equal factors. A factor, for example, a factor that you could use would be, so we know B is correct. Let's say we use B. To get from 2 to 10, you multiply by 5. To get from 3 to 13, you don't multiply by 5, which means there is no multiplicative relationship. You see how like I didn't use this original ratio to solve. I used something that was already given to me to help me figure that out. D, right? To get from 6 to 2, I know I divide by 3, and 9 divided by 3 is 3. So that is also incorrect. To get from 9 to 18, I multiply by 2. And to get from 6 to 12, I multiply by 2. I can also use an answer that I use, right? To get from 3 to 18, I multiply by 6. And to get from 2 to 12, I multiply by 6. So there is a balanced multiplicative relationship between 9 6 and 18 12. If you got this correct, shout outs to you. Once again, you're understanding ratios. You should feel really confident about when you see ratios on the middle of the year diagnostic. Now let's take this ratios to another step. Hopefully you can see this. A mixture of orange paint, this is me annotating my information, contains 8 teaspoons of red paint. I'm gonna write 8 teaspoons of red paint and 12 teaspoons of yellow paint. We know that together they create orange paint. To make the same shade, which means it's equivalent, whenever you see same shade, it means an equivalent ratio. Of orange paint using 18 teaspoons of red paint. So using 18 teaspoons of red paint, how much yellow would you need? So that brings us to our find. Clearly, that's what we're finding, right? And so we could use a double number line or we could use a table. I like to use a table because it really helps me like visually see what I have in a more organized way. So first I want to list information that I have. I have red paint and I have yellow paint. I'm not going to put orange because it's asking how many teaspoons of red paint, how many teaspoons of yellow paint if I have 18 teaspoons of red paint. So I'm only dealing with red and yellow, and then that together will create the orange. So what information is given to me? I know that there are 8 teaspoons of red, 12 teaspoons of yellow. And I need to figure out using 18 teaspoons of red. Usually, I would put 18 here, but is there I like to put it on the outside. Is there a multiplicative relationship between 8 and 18? No. So you want to skip the middle and put 18 here. Now, what is a multiplicative relationship or a number that can be multiplied into both 8 and 18? Is it 1? Yes. Is it 2? 2 is a very even number, so you can use 2. You can't use 3 or 4 because 4 goes into 8, but not 18, right? 3 goes into 18, but not 8, right? So let's use 2. In order to get from 8 to 2, you want to divide by 4. What you do on one side, you do on the other. And you know that when it's 2 teaspoons of red paint, there should be 3 teaspoons of yellow paint. But that's not what it's asking for. It's asking when there's 18 teaspoons of red, how much yellow? So you got to figure out, how do I get from 2 to 18, which is to multiply by 9. What you do on one side, you do on the other side to create a balanced multiplicative relationship. And 3 times 9 is 27. We found our answer. All right. If you got this right, this is really good. This means you now understand like word problems and ratios, and you're on a 6th grade level with ratios, which is really good. Now let's look at unit costs. So 3 concert tickets cost $45. So 3 tickets, $45. Do you see, as I'm literally reading, I'm writing at the same time? 3 tickets cost $45. At this rate, what is the cost per? And here's the hint, per. When I think of per, it means 1. So let's create a model using the information that we know to figure out what we can find. We're dealing with tickets and cost, right? We know that 3 tickets cost $45. we need to figure out the unit rate or the cost per one. So we could do it multiple ways. We could say if we divide 3 by 3 and 45 by 3, we get 15. Or we could say, well, let's find 1. To get from 3 to 1, you divide by 3. And to get from 45 divided by 3, you get 15, which means the cost per ticket is $15. Not bad. If you got this right, shout outs to you. You're really starting to understand rates, and this is the 6th grade standard, so this is all really, really, really great information. Now let's read another one. 3 milkshakes cost $9.75. So 3 milkshakes cost $9.75. Okay. At this rate, how much do 2 milkshakes cost? Ooh. So let's use the information that we know to try to figure that out. So we're dealing with milkshakes and we're dealing with costs. We know that 3 milkshakes cost $9.75. We're trying to figure out the cost of 2. Is there a multiplicative relationship between 3 and 2? No, there actually isn't. So you want to put 2 at the bottom and find what's the multiplicative relationship between 3 and 2? 1, right? You could also use 6 as like a grade, like a multiple to help you, like the common multiple. But I like to use a common factor because it helps us. To get from 3 to 1, you divide by 3, and 975 divided by 3, which would be 3 decomposing 75 and 3 composing 9. If I decompose 75 by 3, I get 25. And if I decompose 9 by 3, I get 3, which tells me that each milkshake costs $3.25. But that's not what the question is asking. The question is asking, how much do 2 milkshakes cost, right? So we need to multiply. 1 times 2 is 2, and 325 times 2 is $6.50. So now you know that 2 milkshakes cost $6.50. Let's keep going. 3 oranges cost $1.35. At this rate, how much do 5 oranges cost? So let's create a model of the information we have. We're dealing with oranges and we're dealing with cost. We know that 3 oranges cost $1.35. We're trying to figure out how much do 5 cost. Is there a multiplicative relationship between 3 and 5? No. If there's no, you skip a row and you put 5 there and you find a common factor between 3 and 5. And that is 1. 3 divided by 1 is to divide by 3 on both sides. Now we have to divide $1.35 divided by 3. Let's do some division. Whenever my dividend has a decimal, I go ahead and raise it up. I know 1 can't open the door for 3, so there's nothing going to be there. But 13/10 can open the 3. 3 goes into 13/10 4 times. That'll give me 12/10. And then pull down your shade. 3 goes into 15 5 times, which means that each orange costs 45 cents. But I'm not done because it didn't ask for the unit rate of 1 orange. It asked for 5 oranges. So we have to multiply by 5 on both sides. So now we got to do 45 times 5. And we learn how to multiply fractions. 45 is 4500 times 5, 1. Now we just got to multiply 45 times 5. 5 times 5 is 25. 5 times 4 is 20 plus 2, which is 22. So it's 225 over 100. And we have to turn that into a decimal. And if it's 100th, we move the decimal place 2 times, which means that 5 oranges cost $2.25. So far, so good. If you understood that, you're on the right track to doing some amazing things, and I'm so proud of you. All right. Now, Lynn's family has completed 60% of her trip. It looks like we're dealing with percentages. Okay. They have traveled 30 miles. Hmm. So let's just look at this. So let's say this is the destination and this is the start. So it looks like they traveled 60%, but it say they traveled 30 miles. Did they travel the whole part? No. So that tells me that 60% is equivalent to 30 miles, right? Now, what are we finding? How long is the whole trip? Whole trip equals total, and total equals 100%. So let's create some type of ratio table model to help us. What are we dealing with? We're dealing with percentages and we're dealing with miles. We know that 60% represents 30 miles. We're trying to figure out the total trip, which is 100%. Is there a multiplicative relationship between 60 and 100? No. So we go ahead and put that down. And what number is a multiplicative relationship between the two, or the greatest common factor between the two? You could do 2, you could do 5, you could do 10, but the greatest common factor is 20. So now we're going to start figuring this out. To get from 60% to 20%, you have to divide by 3. And what you do on one side, you do on the other, and 30 divided by 3, which is 10. So every 20% is 10 miles. So now we got to go from 20% to 100, which is to multiply by 5. And we have to multiply 10 times 5. That will give us 50, which means that 50 miles is the whole trip. And we have an answer. Let's move on. It takes Andre 4 minutes to swim 5 laps. So 4 minutes to swim 5 laps. Okay. How many laps per minute? Which means 1 minute. Okay. So let's create a ratio table to represent this. We're doing minutes to laps. And we know 4 minutes swims 5 laps. Okay. But we're trying to figure out how many laps for 1 minute. So we want to put a 1 here. To get from 4 to 1, you want to divide by 4, and then you want to divide by 4, which is 5 divided by 4, which is 5/4, or you could say 5 divided by 4. 4 goes into 5 one time, 4 goes into 10 two times. Don't forget to raise up your decimal. It's an 8, that's a 20. 4 goes into 25 times. And 5/4 equals about 1 in 2,500. So we know that's 1 in 2,500 laps per minute. Now, how many minutes per lap, which means for 1 lap? So here you want to put 1. To get from 5 to 1, we divide by 5. And we have to divide 4 by 5. So that's 4/5. So let's see if we could 4 divided by 5. 4 is first, so which means 4 is a dividend, divided by 5. 4 can't open the door for 5, so you have to put a decimal point, raise it up in a 0. Well, 40 divided by 5 is 8. 8 times 40 is 40. So we know that's about 0.80. 0.80 minutes per lap. Okay. Now, if Andre swims 22 laps, how long does it take him? Well, To get from 1 to 22 is times 22, and we know it's 4/5 per lap. So we just multiply 4/5 times 22, and every whole number is over 1. 22 times 4 is about 88. 88 fifths, which means 88 divided by 5. 5 goes into 8 one time. 1 times 5 is 5. That's a 3. Bring down the 8. 5 goes into 38 7 times at 35. 3. Bring down the decimal. Bring it up. 5 goes into 36. There are no remainders. So it takes about 17.6 minutes to swim 22 laps. Okay? If you got this one, you should call yourself a champion because you're definitely moving into like mid-level 6th grade material within ratio. Really good. Let's keep going. Now let's listen to this. Calculators should not be used. So there's no calculator for this. So Priya ran 1.5 miles today. Tyler ran 3 3/4 miles. Okay, so Priya ran about this much. Tyler ran about this much. We got to figure out how many times the length of Priya's run was Tyler's. So if Priya represents 1.5 times a value, and this is a variable, an unknown value equals Tyler. Right? And to solve this, we have to get the variable by itself using inverse operation. So if this is being multiplied, the inverse operation is to divide by 1.5 on both sides. That cancels out so that the variable is by itself. So now it looks like we just have to divide 3 3/4 by 1.5. First, we need to convert these mixed numbers into improper fractions. 4 times 3 plus 5 is 12, 15, and keep the denominator, which is 4, divided by 2 times 1 is 2, plus 1 is 3, over 2. Now, usually, we would have to multiply by the reciprocal, but can we divide 15 by 3? Yeah, 15 divided by 3 is 5. Can we divide 4 by 2? Yes. 4 divided by 2 is 2. So it's about 5/2. Do we see that? Yes, we do see that. It's right here. If you got this, then you're doing really, really well on dividing fractions, and I'm so proud of you. Now let's look at this. Which statement shows the correct reasoning to finding 12 divided by 3/8? Well, first, we know every whole number is over 1 and is divided by 3/8. Ask yourself, can you divide across? Well, you can divide 12 divided by 3, but can you divide 1 by 8? No, because it'll be a decimal, which means you have to multiply 12 over 1 by the reciprocal, multiply that by 8 over 3. 12 times 8 is about 96, and 1 times 3 is 3. So let's ask ourselves, what do we do? Do we multiply by 12, multiply 12 by 8, then divide by 3? Yeah, 12 times 8 divided by 3. That's an option. We multiplied 12 times 3? No, we didn't do that. Did we multiply 3 times 8? No, we didn't do that. Did we multiply 12 times 1/8? No, we didn't do that. And that's known as process of elimination. So we know our answer has to be A. If you got that right, kudos to you. I'm so proud of you. Let's go to this one. It says a sign-in bakery gives these options: 12 muffins for $25, 24 muffins for $46, and 50 muffins for $94. Find each unit price, and unit means for one muffin, to the nearest cent. Okay, and show your reasoning. Well, we have three options, so we want to create three representations. We know that we're dealing with muffins and cost, and we know 12 muffins cost $25. We're trying to find the unit rate, which is to divide by 12 on both sides. And that means 25 is being divided by 12. 12 goes into 25 two times at 24. Then you have 1. Put your decimal point, raise it up, 10. Now, after you subtract and pull down, you want to divide. 12 goes into 10 0 times. So that's 0. And then that's a 10, then that's a 0. 12 goes into 100 about 8 times at 96, and that's a 4. You want to keep this here, right? Because we're dealing with cents. So we don't need to go pretty much any further. But if you did want to do one more, 12 goes into 40 about 4 times, which means it'll be about $2.08. This 8 is not going to round up because it's set to the nearest cent and not nearest 10 cents. The 4 does not round the 8 up, so it's about $12. It's about $2.04, right? Let's look at this one. We're dealing with muffin and we're dealing with cost. And we know 24 muffins cost $25. We're trying to find the cost. Oh, sorry, $46. Trying to find the cost of 1. So we know we have to divide by 24 on both sides. So we're doing 46 divided by 24. 24 goes into 46 one time because 2 times 24 is 48, and that's too big. So I will do 24. 6 minus 4 is 2, and that's a 2. Bring down your decimal point and a 0. Ooh, 24 goes into 220. Well, I know 24 goes into 10 240 times, so maybe we could do 24 times 9, which is 36. Yeah, 216. 9 times 24 is 216. That's a 4. And 24 goes into 40 one time. Right? So it's about $1.91, maybe 92, right? For each muffin. If you're getting these right, I'm so proud of you. You are going to crush the MOI. Now let's do the last one, muffins and cost. We know that 50 muffins cost $94. We know we wanted to get to 1, so you have to divide by 50 on both sides. We have 94 divided by 50. 50 goes to 94 one time at 50. That's a 4, right? 44. After you subtract, you bring down. So 50 goes into 440. I know 50 goes into 100 2 times. So 200 4 times, 300 6 times, 400 4 times, 8 times. So you see your decimal point, you want to raise that up, and that's about 8, about 400. So it's about $1.88 per muffin. So one of the choices is $2.04 per muffin. The other choice is $1.91 per muffin. And the last choice is $1.88 per muffin. For me, the best option, it didn't ask for it, but the best option is 50 muffins for $94. If you got all this right, you better go. And if you didn't, it's okay. What did you learn? What did you do? I know a lot of students struggle with raising up that decimal point. That decimal point really creeps in there. So make sure you remembering to do that. And this is the last page for part one. Now, this is extremely important because I'm teaching you something that I didn't really teach you, but if you were on sixth grade, you would have learned, right? This is what you call a power. A power is an exponent that is at the top and it's small. A power means that you're multiplying by the same number to the amount of the power. So multiplying by the same number to the amount of the power. So for example, 7 to the 3 means 7 times 7 times 7. Oh, and that's A. It's not 21 because 7 times 7 times 7 is much greater than 21. It's not 3 to the 7 because the base is 7. The base is not 3. And it's definitely not 10 because 7 times 7 is 49. Okay? Which expression is equivalent to 45A minus 10B? What? I know you are looking at this work like, what are you talking about? Right now, I'm going to give you a really quick introduction to distributive properties. So write it on your paper. Distributive property, right? Distributive property is when you multiply a number A by the sum or difference of two numbers or two or more. So for example, we have A and we have B plus C. A is just being distributed into B and A is being distributed into C, which will make it AB plus, that's this one, AC, and that's this one. So we're going to practice distributive property to see if we can find our answer. So this says 5 groups of 9A, the difference of 9A and 10B. We're going to distribute that 5 into 9A, and then we're going to distribute that 5 into 9B. Pay attention to the variable, right? The variable is the letter amount. 5 times 9 is 45, but don't forget that variable. Minus 5 times 10 is 50. Don't forget that variable. So is it 45A minus 50B? No. Now we're using process of elimination. Let's look at this one. 45 is being distributed into the difference of A and 10B. 45 times A is 45A minus 45 times 10B is 450B. Is that the same as 45A minus 10B? No. Let's look at another one. 5 is being distributed to 9A, the sum of 9A and 2B. 5 times 9 is 45. Don't forget your variable. plus 5 times 2 is 10. Don't forget your variable. Is it 45A plus 10B? Well, not necessarily because of the operation. It's subtraction, so we need to find the difference. So let's see if we could do it with this one. 5 is being distributed into 9A, the difference of 9A and 2B. 5 times 9A is 45A minus 10B. Did we find it? Yes, we did. And so D is our answer. Ask yourself, why is C not the correct answer? And why is D the correct answer? And how well do you understand distributive property? What I want you to do is I want you to solve this one on your own. This will help me understand how much you understand distributive property using process of elimination. Now, here's an expression. We know this is an expression because it's no equal sign. You see that? However, this little t here is a variable. But here it says t is 1. So we found the solution to the variable. So this is saying 2 plus 3 to the 1. Whenever we have a variable to the 1, that means the number or the base. So whenever variable or exponent, because that's what it is 1, the base is itself. So which that means is 2 plus 3. Because anything to the first power is itself, and 2 plus 3 equals 5. Now, let's see this one. What changed? T is now 4. So you have to substitute the variable by the solution. So here we have 2 plus 3, substitute t for 4. And I'm going to put parentheses here because when you're solving equations, you want to follow a certain order. And in the order, exponents, which is the 4, comes before adding. So first you got to solve this. And 3 to the 4 does not mean 3 times 4. It means 3 times 3 times 3 times 3. It's 3 times itself, or the base times itself, to the power of 4 times. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So we know that is 81 plus 2, and 2 plus 81 is 83. You want to double check your work? 9 times 3 is 27. 27 times 3 is 7. 14, 21. 21. 3 times 2 is 6. 7, 8, 81. And an 81 plus 2 is 83. And that's all for part 1. If you felt successful, then you could already just count yourself 6th grade ready. On mothers. If you felt successful in all of those problems, go ahead and count yourself 6th grade ready. And the middle of the year will show that you are prepared and you are on the 6th grade level. And you should pat yourself on the back because it means you should be proud of yourself. Stay tuned for part 2.